All right, everybody, I am here doing exponential functions. We are talking about growth and decay. This case, we are talking about decay because we have a computer that's valued at $6,500 and it's depreciating at a rate of 14.3%. And that is per year. We're looking to write the function that models that value of the computer and then finding out what the computer's value is after 3 years. So let's start off with writing down what we know. So we do have a value of $6,500, which is what our starting value is, or our initial amount. So we are going to start off with f of x to write out our function. We will then put our value that it starts with, which is 6,500. And then we're going to be multiplying. We are talking about depreciation of an item. So we're going to multiplying. This is going to be an exponential function. Again, when we look at the functions of decay or growth, we're always talking about 100% of what the item is. Now, it either is going to grow past 100%, or it's going to decay or decrease in value, and that means we're going to subtract from 100%. So in this case, our percentage rate is 14.3%. So we want to change the percentage to a decimal. So we would move this decimal 2 places over to the left to make it a decimal, which would be 0.143. Now, 100% as a decimal would be just 1. And so we would subtract because we are talking about the word depreciates. So depreciates means it's going down. So we're going to subtract 0.143 from the 1 value. And then we would write to the x exponent or whatever variable we're talking about. In this case, I'm just going to say x. So that is how we would write the function. You could obviously use different letters to describe this, but in this case, that's what we're going to go with. And so we would do that. And if I want to find out what that decay factor is, all I would do is take 1 minus the 0.143. And then when I do that, I end up with a decay factor of 0.857. So if I want to clean this up and make it a little bit nicer looking, I would write this as f of x is equal to 6,500. And then in parentheses, 0.857 to the x power. So that's how I would write this function neatly. And then if I want to know what the value is after 3 years, that's going to be what my value of x is going to be replaced with. So when I'm replacing the value of x with 3 years, I'm going to write f of 3, and then I'm going to replace using that function. So 6,500, parentheses 0.857, and we're going to place that to the third power. So in my calculator, what we're going to do is we're going to do 6,500 and then times, and then I'm going to put in parentheses that 0.857, and then I'm going to put to the power. We'll do that little button right here, this button, and then I'm going to put it to the power of 3, close my parentheses, and my answer is $4,091, and we're going to do 25 cents because this is 2 decimals, we're talking about money. 4 would round up because that 8 is going to change that up to a 5. So the answer would be $4,091.25 after 3 years of depreciation. If you want more questions like these, find them on my YouTube, Instagram, and TikTok at YouWantAlgebra. All these are going to be located in the exponential functions section. Don't forget to share, like, and follow for more.